Hi, welcome to my video on the quotient rule of exponentials. The quotient rule, which means division. Remember, we did the previous video was on multiplication. When you multiply exponentials with the same base, you add the exponents. So division is the reverse of multiplication. So the quotient rule will be what? Multiplication you add, division reverse, probably subtract. Well, let's look at a couple of them and see. Number one, 2 to the 5 is 2 times 2 times 2 times 2 times 2 over 2 cubed is 2 times 2 times 2. Now that we're dividing, we can cancel. Yeah, I'll get ones when we cancel because 2 and the 2, 2's cancel, 2's cancel. So that gives me 2 times 2, which is 2 squared. And if you notice, a 5 and a 3, 5 minus 3 gives you 2. So you're subtracting, because multiplication, you're adding the exponents, division, you're subtracting the exponents. Let's try number 2. 3 to the 6 is 3 times 3 times 3 times 3 times 3. 6 times, divided by 3 times 3 times 3 times 3 times 3. 5 times, cancel, 1, cancel, cancel, cancel. And I'm left with a 3. And notice the 3 is the same as 3 to the 1. So 6 subtract 5 is 1. Again, we're subtracting. So the quotient rule is, notice you have the same base, b, same base is 2, same base is 3. So you keep the same base and you subtract m from n. Notice the base cannot be 0, and m and n belong to the integers. So we're only dealing with integral exponents. When two exponentials are divided, provided they have the same basis, the exponents are subtracted. So multiplication is adding with the same base, division is subtracting. Let's work out some of these examples now. Notice, simplify each as an exponential b to the m. So 5, 6 minus 2 is 4. The base is 7, right? But 7 is to the 1 power, understood to be a 1. So 10 minus 9, 10 minus 1 is 9. And the base is 10. So because you're dividing, you subtract. 8 subtract 5 is 3. We're dividing, so the base is 2. So 9 subtract 7 is 2. And we have the base is x, same base. Because we're dividing, we subtract to get 3. Because we're dividing, the base is a. We're subtracting. 3 subtract 2 is 1. And a to the 1 is understood to be a. G, base is c, so we're subtracting. 11 subtract 8 is 3. The base is 3. Because we're dividing, we subtract. 2 subtract 2 is 0. And 3 to the 0, any number to the 0 power is 1, except we cannot have 0 to the 0. And y is the base, and we're dividing, so we subtract the exponent. 2. 8 subtract 6 is 2. Practice. Pause your video, work the 6 of these out, and then play it back to see if you're right. The base is 3. Because we're dividing, we subtract 6. That's a 1. Because the base is 2, 10 subtract 1 is 9. The base is 11. We're dividing, so we subtract the exponents. 4. We're dividing, so we subtract the exponents. 3. We're dividing, the base is d, so we subtract and get a 3. The base is y. Because we're dividing, we subtract, we get a 4. Okay, one page worked out. Let's try the next page. Notice we want to simplify these as exponentials as b to the m. Notice the base, the only thing you can't have is the base is 0. So we have a base of a negative 7, and we're dividing, so we subtract 2. The base is 3 over 5, And because we're dividing, we subtract. 11 minus 9 is 2. Because we're dividing, we have the same base of a negative 3. Because we're dividing, we subtract. 10 subtract 2 is 8. We keep the same base. Pause the video, work out the 3 of these. Because the base is negative 2, we subtract to get a 4. Because the base is a negative 6, notice it's in brackets, we subtract and get a 7. Because the base is 1/4, we're dividing, we subtract, we get a 5. Combination, so now we're doing a multiplication and a division in the same problem. What I do with these is that if I have a fraction, I simplify the numerator first. So because I'm multiplying here, I will add. The base is 2, so you add to get a 10. So I simplify the denominator and the numerator, and then I deal with the division after. And because we're dividing, the base is 2, 10 subtract 6 is 4. And again, the 3 has a 1 here, and because I'm dividing, I will simplify the top. Because I'm multiplying, I will add 11 and 1 to get 12. And because I'm working the bottom now, because I'm multiplying, I'll add 3 and 5 to get 8. That brings me to a division. The base is 3, so when I divide, I subtract. I get 4. Again, simplify the top, simplify the bottom, and then work it out. You'll never go wrong with fractions if you simplify the top and simplify the bottom, and then take care of the division. Again, the x has a 1, just to make sure. And because we're multiplying, we add and get a 12. The exponential, the base here is x, and because we're multiplying, we add. So the numerator is done, denominator is done, and the base is x, and we are dividing, so we subtract to get a 5. D, we have the top is okay. The top is 9, a to the 9, that's all right. The bottom is both bases are a, so it's when we multiply, we add. Good. Now we have that simplified, and now we're dividing, so we keep the bases a. 9 minus 6 is 3. E, we have a multiplication and a division. Well, the base is d. That's all the base is d, so we can say when we multiply, we add, and when we divide, we subtract. That makes sense. Multiplication, add exponents, divide, you subtract. So that gives me 13 subtract 2 is 11. F, what we can do is work out each one of these separately, or we can multiply. It's your choice. I can work out this fraction, y to the 13 take away 3 is 9. And we're dividing here, so y is the base, so 8 subtract 7 is 1. We can put a 1 there or leave it. And because we're multiplying, we can add. We have the same basis still, so 9 plus 1 is 10. Okay, just a little mixture, but I always simplify. Here I simplified each fraction first, right? Over here, I simplified the numerator and then the denominator, and then I worked out the division. Just be careful. And we have a simplify as an exponential b to the m. And again, this is a practice. Practice means pause the video, work these 7 out, and when you get them done, play it back to see if you're right. Okay, here we go. We're multiplying on the top, so we have the same base as 5, so 9 plus 6 is 15, all over 5 to the 12. Because we're dividing with the same bases, we write down the base, and we subtract. 15 subtract 12 is 3. And notice, let's work the top, which is the numerator. Let's work the bottom, which is the denominator, and then divide. 7 is the base on top, we add 12. 7 is the base on the bottom, so we add to get 11. And because the bases are the same, I can write down the base of 7, and 12 subtract 11 is 1, which is 7. Again, Multiplying, you add, but you got to have the same basis. Dividing, you subtract, but you got to have the same basis. And number 3, we have a 1 understood there. I put the 1 in, so make sure you don't miss it. I know, again, if there's no exponent on the variable or on the number, 1 is always the exponent. Because we're multiplying, we add. Again, there's y's here, so we have a y, we add 6. We got to have the same base. Because we have this base as y, we're able to divide and we subtract the exponent to get 3. And c to the 16, we simplify the bottom, that's a 1. And because we're multiplying like basis c, we add. And because we have same basis, c, we subtract. We divide 6. Number 5, E, same base. The base is E. So when we divide, we subtract 12, subtract 5. And divide again, we subtract 7. So 12 subtract 5 is 7. 7 subtract 7 is 0. E to the 0 is 1. Any number to the 0 power is 1, except 0. And number 6, we simplify the top, simplify the bottom. A is the base in all of these, but that's a 1 there. So when we're multiplying, we multiply, we add the 6 to get 7, and we add 11, we get 18. On the bottom, we have bases as A, so we write down the A. Because we're multiplying, we add 5 and 5, we get 10. Now we're dividing. Same basis, base is A, so we subtract. 18 subtract 10 is 8. And number 7, we simplify the top. Because we have the base x, same base, we add the exponent 14. Remember, we're multiplying, so we add the exponents when the bases are the same. Write down x to the 8th. Now we're dividing with the same basis, so the base is x, and 14 subtract 8 is 6, because when you divide, you subtract the exponents, provided the bases are the same. That's a little review on what we call quotient or division of exponentials. And again, when you're dividing, you subtract the exponents, provided the bases are the same. If you liked the video, click on the like button, the subscribe button, the notification bell, because more videos are coming. Write a comment on the video if you wish, and visit my math website, www.mathfullyexplained.com. Information about me, my degrees and teaching experience, section on talking about the videos. That's going to be the teaching strategies they're going to use to help you learn. There's a section on content, tells you about the topics or the units and the number of videos on those topics. And in black font is what is already online, and the topics and that's in red font will be developed in the near future. Thank you very much. Bye-bye.